Are in New York City. We're actually at the Lucerne Hotel, just down the street from the American Museum of Natural History. And with me is Neil deGrasse Tyson, astrophysicist, director of the Hayden Planetarium at the AMNH. Thank you for walking down here. And I want to do a follow-up on the last conversation we did. And we emailed.
Did we talk about enough in that conversation?
No, because obviously, because I'm so excited my glasses are falling off here. We said we were going to do a number of things, and I looked at the transcript of what we talked about last time, and in your last email to me you said with video and high bandwidth nobody reads transcripts anymore. So, plus transcripts lose all interpersonal signals which are fundamental to a live interaction. So,
leaving me to wonder why you would transcript anything at all.
Well, because people at home find this stuff useful, actually.
What people?
They look at this.
Anyone with a computer, if they have the option to watch the video, would surely watch the video.
But what do you think they're losing in reading a transcript?
Everything. Yeah, if I were an automaton, then there's no difference between my words and the transcript. But I'd like to think that I'm a human being interacting with you at a time and a place, in a moment. And that involves pauses between words, expressions, what your eyebrows do, whether something was thought of as humorous by the interviewer. These are cues, nonverbal and interpersonal cues that I think are fundamental to human communication. And anyone who believes that a transcript somehow captures what happened cannot possibly be a communicator themselves. I don't know what it is they're valuing. They think the word is the means of communication that matters. And most of human interaction that we value doesn't even come through words.
Okay, 2 points there. First of all, this is a useful referential tool, however, to go back and see what was actually said. Your second point, which is a good one, the whole notion of social...
So does the sliding button on a video.
social interaction.
That happens
right?
even a little faster, but go on.
But the social affective neuroscience, there's an entire journal on this sort of stuff right now, and you're exactly right. There's a great deal of new work in neuroscience, which is looking at interpersonal communication, how people interact, facial expressions, so on and so forth. There's an exhibit going on right now at the American Museum of Natural History on the brain, right? Were you involved in that?
No, not at all.
But
no, we have whole teams of people and as the subject of new exhibits shifts from one subject to another,
yeah.
I should say as the themes of exhibits shift from one subject to another, we tap different scientific expertise among the departments of the American Museum of Natural History. The brain is not astrophysics, so I was not involved.
However, as host of Nova Science...
Except I have a brain,
right?
So that I care, but I wasn't involved in designing it.
But as host of Nova Science now, you must deal with neuroscience subjects.
Multiple times
and
we
you
have.
must have some thoughts about neuroscience. And you said in your email to me, happy to talk about the brain. I have opinions on where neuroscience can and should go.
I do.
Those opinions would be?
Oh, I think neuroscience is the future of any understanding of who and what the human condition is and is all about. The behavior, one of the great challenges, of course, is you can't stick a person in a box and perform brain experiments on them. You can't do that ethically or legally, and so the brain, it seems to me, is one of the most intractable subjects of a scientific investigation. And so for that reason, neuroscience has lagged other sciences in where we are and how far we've come, and it's understandable. But by the same token, it has the most yet to reveal to us about human behavior, about mental illness, about what drives our emotions, our hate, our love, our passions. There are people who are certain that these are places science will never reach. In fact, they almost boast. They'll say science will never explain love or never explain why we like a work of art. And so I ask them, do you say we'll never do it because you don't want us to ever do it? Or because you don't think it's possible? Because I can imagine tests for what love is, for whether or not you'll like a painting. It's not too hard to imagine. Consider, for example, we map the entire neurosynaptic phenomena in the brain. Then you put a painting in front of the viewer and watch what gets fired in their brain. Okay, watch which parts are excited. That's interesting. Show that same painting to other people who also like it. If the same part of the brain is getting stimulated, then there's a cause and effect here about the content of a painting, a stimulus, a visual stimulus, and the reaction of the human brain to that stimulus. So if you do that enough times, you could invert the experiment and say, what happens if I put a painting in front of you and purposely tickle that part of your brain? What would you then feel about the painting I put in front of you? I bet you, and this is plausible, that if I put a blank wall in front of you, tickled the part of the brain that you expressed when you liked a painting, that you'll like that blank part of the wall. I bet you. That's my bet. If these tests come out in this way, I think it tells us, it will tell us, that all emotion is simply what gets stimulated in your brain and what does not. All belief systems that are not evidence-based would be triggered by simply what gets triggered in your brain and what does not. And so that is all, I think, in the future of neuroscience. And if it doesn't reveal itself that way, that's interesting too. If the two of us love a painting or sculpture or work of music, and different parts of our brains are being stimulated, that's interesting. That tells us it's more intractable than we ever imagined. I'd want to know that as well. But all those answers are going to come from neuroscience. It's not going to come from psychologists. It's not going to come from physics. People imagining that quantum physics is somehow, I think that's overreaching at this point.
Devil's advocate position would be that you're describing a kind of a reductionist position there, that, you know, all we are is our brains. Right?
The word reductionist fascinates me because it's such a label. You're a reductionist and you're not. And I don't think of those thoughts in that way. When I think of what I do, I ask, brain is a pretty mysterious place. We don't understand it yet. Let's part the curtains and see what's behind it. That's quite natural, I think. If you want to label that reductionist, okay. But so much of the world we learn about by sort of unpacking it and disassembling it. It's like, hey, look what we've learned that we didn't learn before because we didn't know how to unpack it. You want to label that reductionist? Okay. It's just not how I label myself when all I'm doing is trying to understand the operations of nature.
Yeah. Lots of crowds coming for that exhibit. I would have thought, the neuroscience stupid is my view on this at this point. I agree with you that there's a great deal to be learned. It's enormously revelatory.
Right, to say that if you're going to ask, do I think all we are is our brains? That's a good start. Is all we are our elbows or toes? Brain, that's a really good place to start that line of questioning.
Right.
To say, is that all we are? Isn't that a lot? Isn't that kind of something to be proud of? Why the attitude? Is that all we are, our brains? I mean, that's a pretty powerful statement to make unto itself. I say, that's all we are. That's amazing. This, 3 pounds or whatever it weighs of matter between your ears that deduces the nature of the cosmos.
And allows people to come up with thoughts that are described as being astrophysics, for example.
Indeed, and also thoughts that are culturally regressive. The whole gamut of how to think comes out of our brain. What fascinates me is all the ways the brain fools us. How the brain prevents our senses from obtaining accurate information about the world around us. That fascinates me to no end. And why did it take so long for science to gain hold as a way of understanding the natural world? It must be because our brain isn't wired scientifically. Otherwise, it would have been the first way we've ever imagined to understand the world, rather than inventing goblins and demons. And I mean, just look at the history of human culture and the stuff we invented just to account for what's around us. Science is a relatively late-coming conduct of cultures and of the human mind. So science is something to be proud of. It allows us to understand the world in spite of ourselves.
Right. You did this whole notion of belief and explanations that people come up with in the absence of evidence. On your website, at the Hayden Planetarium, the Neil deGrasse Tyson website, there's a couple of clips of two things you did in this last month. One was a Colbert show, and one was a couple of days ago with Jon Stewart, The Daily Show. The Colbert one was very funny, because you sort of just happened to turn up on the show when he was talking about Bill O'Reilly's explanation of there must be a God because sun goes up, sun goes down, tides come in, tides come out, and you went on and explained how the tides really work. That was I mean, what was the setup there? What was the story?
Well, you know, Colbert is always poking snide fun at so much of what goes on in the previous day's news cycle. And they came upon Bill O'Reilly in a rebuttal to a conversation with the head of the atheists organization. And he says, tide comes in, tide goes out, you can't explain that. And so Stephen Colbert, between shows, imagined that I probably could explain it and invited me on for this little ditty, which is quite entertaining. But I was there simply to say, this is how and why tides work. It was Stephen Colbert who then said, oh, so if only God can explain the tides, and Neil deGrasse Tyson, an astrophysicist, explains it, then Neil Tyson is God. Using Colbertian logic to come to that conclusion. So it was a fun bit. But yes, the world looks mysterious if you don't know physics. Physics 101.
The Jon Stewart one you were talking about is a special you have coming up, or is the new season?
That was just last night.
This is the
Yes.
new season of.
Yeah. I don't know where you were last night, but it was on TV.
We were actually at the book party for Brian Greene's new book, which we'll get to in a minute. But so tell me what that was about, and you
so
have a
we
new
just
season coming up, or
so in this spring 2011, we launched the 5th season of Nova Science Now. And organized slightly differently from previous years. Previous years, there were science segments sort of stapled together in a 1-hour-long program. We still have science segments, but now they're themed to address specific questions that drive the content. This first show, the premiere show, was Can We Get to Mars? Answered from multiple angles. Tell me about spacesuits, the radiation from the sun or from the galaxy, food storage, propulsion. So we come at the story from multiple angles, all addressing that same question. Other shows, one is Can We Live Forever? One is How Does the Brain Work? Another one is What's the Next Big Thing? So it allows us to sort of shape our discussions more coherently when the show is being discussed.
rather than just a potpourri. That's
Yeah, I happen to also like potpourri, but it's harder to tell another person how to wrap their brain around what it is we had in mind for the show.
So when does What's the Next Big Thing coming up? And
I have to recheck the schedule.
What is the next big thing?
Every couple of weeks.
Can't tell you at this point.
You have to watch the show.
All right. So this Mars thing that you were talking about to Jon Stewart, you said that was one of the things that particularly grasped you. I mean, and it was
we lead off with
the
Can We Get to Mars?
practicalities of it, wasn't it? The sheer.
Yeah. And there's another dimension of this that doesn't go as recognized as I think it should be, and that is what's the psychological state and health of the astronauts. Once they leave Earth, they're gone for 3, maybe 4 years in the same confined space with the same set of other people. So maybe you need really socialized people, or you can go the other extreme and maybe be just as stable by putting sending 6 hermits aboard who don't want to talk to anybody and are just fine being alone. You give them some really thick novels and a Netflix account, and they don't need to talk to anybody. I mean, I don't know what the answer to that is, but it doesn't have an answer yet because we haven't had to think about that problem. And yet it is a very high-ranked issue in the consideration of what it will take to go to Mars successfully.
Yeah, wasn't there a book just came out called Packing for Mars?
Packing for Mars, that's right. I only read the reviews of it, and it was quite entertaining. I didn't get a chance to read the book itself. But yeah, it's trying to think about Mars as what are the practical things you need to consider.
Yeah. All right. Something else I picked up here, another book that came out recently. When we began our last conversation on this hallowed thing, a transcript, we were talking about the demotion of Pluto, and you being called a Pluto demoter. Since then, Mike Brown, Caltech astronomer, has produced a book, and he's basically called. It was called "How I Killed Pluto and Why It Had It Coming." Have you read Mike's book, or did you guys?
Yes, in fact, I wrote a review for it that'll appear in Nature in just a couple of weeks.
Okay,
yes.
so what's the latest stage on the demotion of Pluto and the death of Pluto?
It hasn't changed.
And Mike's thing.
The vote of the folded in with a lot of personal vignettes on how he met his wife, how he juggled the discovery of the largest object in the outer solar system, even bigger than Pluto, with the birth of his daughter. So there's a lot of sort of social, familial storytelling that is mixed in with the science. And in that way, by my read, it made it a rather charming book for those who might otherwise feel uncomfortable venturing into a science book.
Right.
In it, he makes the case that since he discovered Eris, at the time measured to be larger than Pluto, if Eris is not labeled as a planet, then it would weigh down Pluto with it.
Right,
It's bigger than Pluto. And how would you have something bigger than Pluto not be a planet and have Pluto be a planet? And so the premise, How I Killed Pluto premise, is that he discovered something bigger than Pluto that he doesn't think should be called a planet. And if not, then you bring Pluto down with it. And so that would be sort of the killing factor. Recent measurements of the size of Eris place it at slightly smaller than Pluto.
Oh.
Just slightly. And so a lot of the Pluto lovers came back out of the alleys and rose up from the gutters to say, okay, so we can reopen this conversation. No, you can't. I mean, you could, but not officially, because the official definition of a planet didn't care whether Pluto was the bigger or not bigger than other things out there in the outer solar system. It was just an irrelevant fact. And it is interesting whether Pluto is the biggest known or the second biggest known. That's interesting for cocktail parties. That's not a scientifically interesting point.
So I mentioned that you asked where we were last night, and I said that we were at Bill Hazeltine's for this book party for Brian Greene's new book, The Hidden Reality, Parallel Universes and the Deep Laws of the Cosmos. And I'm going to talk to Brian tomorrow and discuss some of this stuff. But this stuff, I find brain science comparatively easy compared to trying to wrestle with all these various different descriptions of how the universe operates. Branes, B-R-A-N-E-S, not brains, multiverses and so on. When you do talks to a general audience, do you have a kind of the Universe 101 story about what the current state of understanding is of everything from, the products of a Large Hadron Collider through to astrophysics and so on? Do you have a...
I'm generally available...
Can you do that?
Can I do that for you?
Yes.
You want basic cosmic understanding 101.
Yeah.
That's
what do you
like.
what do you think reality
Well, I mean,
is?
you will have Brian Greene with you, and he has no shortage of ways to share with you what's on that frontier. I can give you a basic Universe 101, but that'll just lay the bedding for whatever else he puts in it. First, as an astrophysicist, I'd like to be sort of evidence-based. So I can tell you the evidence for the beginning of the universe, how long ago it took place, 13.7 billion years. All evidence tells us that the universe in the beginning was very small, hot, and dense in a period that we call the Big Bang. And over that time, many properties, macroscopic properties of the universe that we see today were forged in those early fractions of a second. We can account for the abundance of elements in the universe, the hydrogen, the helium, the lithium, carbon, oxygen, nitrogen. One of the great triumphs of 20th century astrophysics was tracing the elements of your body, of all the elements around us, to the actions of stars that crucible in the centers of stars that cooked basic elements into heavier elements, light elements into heavy elements. I say cooked, I mean thermonuclear fusion. The heat brings them together, gets you bigger atoms that then do other interesting chemical things, fleshing out the contents of the periodic table that we've all come to know and love, or know and hate from high school, the periodic table of the elements. After that, you might want to ask, where does that all come from? Well, now you bring in a whole other set of people. And collectively, you call them the string theorists. These are sort of the higher dimension string theory people who are trying to ask even deeper questions. Where did the universe itself come from? Are there other universes? And two great, profound areas of ignorance that pervades astrophysics today is what is the nature of dark matter, which might not even be matter, that's just what we call it, dark matter, and dark energy. 85% of the gravity of the universe has an unknown origin. We call it dark matter. We don't know what it is. Then there's some mysterious pressure acting opposite gravity that's making the universe accelerate in its expansion. We know we're in an expanding universe, and we also, by conventional physics, say that, well, we're expanding, but there's all these galaxies, and the collective gravity ought to be slowing down that expansion. The way you toss something up, take your shoe or ball and toss it up. Earth's gravity works on that upward speed and persistently slows it down. Eventually makes it stop and come back. We've known for a long time there's not enough gravity to stop the expansion. But any amount of gravity ought to be slowing it down, at least slowing it down. You look out there, an observation made 12 years ago, published 12 years ago, the universe is not slowing down, it's accelerating. Mysteriously. We don't have physics, an understanding of physics to account for that, but we measure it. So here we are, two profound aspects of the universe. And if you add up the total presence of these two phenomena, dark matter, dark energy, it is 96% of everything that is the universe, which means only 4% of it is anything we know anything about. The electrons, protons, neutrons, life, planets, stars, galaxies, black holes, gas clouds, galaxies. That's 4% of the universe that's the 4% of the universe that we understand. 4%. So we've got people who are trying to come at it from another place. They've got both feet outside the box, trying to come back and meet us somewhere. And more power to them. But they, plus they generally tend to be inexpensive. They're theorists. You give them a pencil and a pad, throw in a computer, they're done. All right? You're done supplying them with the tools of their craft. Yes, we have particle accelerators, where these are people driven by extended projections of the standard model of particle physics. Go for it. Any physics apparatus that explores regimes of energy you have never been before is going to discover something interesting. That's the particle physicist counterpart to an astrophysics. If you build a bigger telescope than anyone has built before, you will see things no other telescope has seen before. You're bound to discover something interesting. Either things you expect to be there, that you extrapolate from your current understanding, or things that show up that you never predicted. Each of those make excellent new starting points to advance a field.
Right. Now, when you talk about these things, somebody in the audience must come up, I assume, and say, well, we only understand 4% of this stuff.
Yeah, that's great.
So
I love it.
how is that different from Bill O'Reilly saying, well, in that case, the rest of it's God, and you guys are you're just expounding beliefs here. You've got no evidence for the 96%.
The difference is we do understand the tides. The tides are part of the 4% we understand. So Bill O'Reilly is giving a list of things that are fully understood. If he had given a list of things that are not understood, okay, that would be a different reaction. And it would be less susceptible to comedic mockery than saying, tides come in and out, you can't explain that. It's like, yes, we can. We've known that one for the last couple of 100 years. Give me a better example. So if he said, there's dark matter and there's dark energy forcing an expansion of the universe so fast that it's accelerating. You can't explain that. Right. We can't explain it. Okay. I don't think he knows enough physics to be able to tell us what it is we don't understand yet. That would have been a more interesting exchange with the atheist guy. I forgot his name, forgive me, but the guy who he was interviewing. Now, if he wants to use that as evidence for God, but then we just have to come back and say, well, doesn't mean if you don't understand something and the community of physicists don't understand it, that means God did it? Is that how you want to play this game? Because if it is, here's a list of the things in the past that the physicists at the time didn't understand. And a talk show you might have conducted 200 years ago would have said, the planets do retrograde? Can't understand that, must be a God. And we'd say, you're right. And then 10 years later, we understand it, so what do? So if that's how you want to invoke your evidence for God, then God is an ever-receding pocket of scientific ignorance that's getting smaller and smaller and smaller as time moves on. So just be ready for that to happen, if that's how you want to come at the problem. So that's just simply the God of the gaps argument. It's been around forever.
So, in fact, people who want to make arguments.
And by the way, wait. And I don't even mind. I don't even care if someone wants to say, you don't understand that, God did it. That doesn't even bother me. What would bother me is if you were so content in that answer that you no longer had curiosity to learn how it happened. If the day you stop looking because you're content God did it, I don't need you in the lab. You're useless on the frontier of understanding the nature of the world. And if the world had been, I'm glad whoever those folks are, there aren't that many of them. Because if they dominated the world, we'd still be in the cave. We would have never left the cave. Because there are mysterious things out there, and God is doing that, and you don't need to know that, and don't even think about it. Where would we be if their understanding of the world ruled the world? So I don't mind it, but just don't prevent others from conducting that investigation themselves.
Yeah. So he could have made a better case if he'd had an astrophysicist as a consultant advising him.
He would have made a different case. Find some physics we don't understand, and if he wants to call that God, no, then you come at him with the God of the gaps argument. But you don't pick something that we can understand, because then you're just object of mockery.
Yeah. 2 days from now, January 22nd, will be the 450th anniversary of the birth of Francis Bacon, not the painter, the great philosopher from England.
It will also be the 10th anniversary of the page 1 New York Times story titled, Pluto Not a Planet? Only in New York. Okay.
Really?
So when that day comes, I'll be remembering that, not the birth of Francis Bacon.
All right. But so in the I mentioned that in the email to you that I wanted to talk about that, and you said philosophers tend to overvalue their actual contribution to the sciences.
In modern times, yes.
You want to celebrate Bacon, but hardly any of us in the physical sciences trace advances in our fields through him.
Yes.
So he wrote some amazing things, as you well know. I'm looking back at this Magnalia Naturae, where he's talking about, he's setting out basically a roadmap of things that need to be understood. So in the sense of setting up a community of scholars.
A good organizer of the prevailing ignorance.
And right, and also somewhat of an inspiration for the Royal Society, which had its 350th anniversary this last year, as a community of scholars. What I'm interested in here is an essay that I want to get you to comment on, that Sir Peter Medawar, who's a great English immunologist, did an essay that he did on the effecting of all things possible, which is Francis Bacon's phrase. And he says that the true aim of science, this is Bacon, is the discovery of all operations and all possibilities of operations, from immortality, if it were possible, to the meanest mechanical practice. So he's setting up this large vision, which tended to be viewed, his book like...
And what year was that?
This would be 1620.
Mm-hmm.
His book...
Because of course Galileo was already doing that.
New Atlantis, right.
Galileo
and he knew
was already doing it and already writing about it. And so when I think of influential writings of that era, I'm not thinking Bacon, I'm thinking Galileo, who actually did experiments consistent with these philosophies of investigation. Hence this split in the road between the physical scientists and who they trace the foundations of their field to, and what philosophers might presume was the influence on the field itself.
Right.
But go on.
Bacon is his vision, especially in that book that he wrote called The New Atlantis, is often construed as being utopian, almost messianistic in a sense. You know, and the science is often thought of in this way, that it's just this giant engine that's going to do everything, brave new worldy, and so on. And Medawar... By
the way, there's less of that interpretation of science in modern times than I would say in the mid-20th century.
Right, and
yeah.
All right. So
after we split the atom, quantum physics transformed our understanding of the foundations of nature. We had Einstein's theories, and we went into space. In that period, happened over such a short interval of decades, 4 decades, 5 decades, that the public, scientists included, were left saying, there's nothing out of our reach at all.
And in fact,
we have the power, but you don't really hear that much that kind of conversation anymore.
Right. So let me wrap these two things together, because
in a way, science was oversold to the public, given how many quick advances had unfolded over that short period of time. We can solve anything. So within decades, it was imagined all poverty would be solved. There'd be no hunger, no energy problems, but we still have problems. And so some people became disillusioned and even resentful of science, having been promised by society as well as scientists of the ending of all of our ailments. So all I'm saying is that this utopian concept, wherever and whenever it began, surely went through to the middle of the 20th century. But towards the end of the 20th century and now, I simply don't see that prevailing in public discourse. That's all.
Right.
I'm making a cultural comment for you.
And your time is correct in the sense that President Roosevelt asked for a report from Vannevar Bush, who delivered it to Truman eventually, suggesting the setting up of a National Science Board, which became the National Science Foundation.
And in there was the
1950,
document,
and
the Endless Frontier.
The Endless Frontier, exactly.
Which it still is, but it's not, it's still an endless frontier. But if you wanted to solve all of your problems tomorrow, that's not, you're looking at it the wrong way.
And what Medawar said in his lecture, in response to the people who found that he was being delivering too much, who thought he was delivering too much of a pep talk about the virtues of science and the endless virtues of science, he said, I certainly want to give the impression that I'm an optimist, but indeed I'm no such thing, although I admit to a sanguine temperament. I prefer to describe myself as a meliorist, one who believes that the world can be improved by finding out what's wrong with it and then taking steps to put it right. And on the Science Network, we in fact say a place for scientific meliorists. So this notion of incremental improvements through the use of science, that's essentially what you've just been saying. not this grandiose vision of something that can solve everything, but steps.
But they're not mutually exclusive. You can take steps and get to a grand vision that's realized.
You said
they're not exclusive.
You said in your email to me, happy to talk about whether the frontier is endless. Wrote an essay some years back called The Beginning of Science, and I looked at that. And maybe you could just very quickly give me some sort of reprise of the thoughts that you had in that piece.
Sure, but before I do that, let me clarify that this notion that science is the path to solve your problems, I think that misrepresents what drives scientists. Do you think when you speak with Brian Greene, he's going to say, I am trying to come up with a coherent understanding of the nature of reality so that I can solve people's problems? Do you think that's what's driving him? Do you think I'm being driven when I look at the early universe or study the rotation of galaxies or the consumption of matter by black holes? Do you think I'm being driven by the lessening of the suffering of people on Earth? Most research on the frontier of science is not driven by that goal, period. Now, that being said, most of the greatest applications of science that do improve the human conditions comes from just that kind of research. Therein is the intellectual link that needs to be established in an elective democracy where tax-based monies pay for the research on the frontier. Because people are saying, why are you researching that when you should be finding a cure for my disease? Okay, and I don't have a problem with that. But did you know that we diagnose your disease using an MRI? And what is the physical principle behind the magnetic resonance imager? It came from a physicist who is an expert in atomic nuclei, wondering how you would detect this in interstellar space. Do you think that physicist, when he came up with this understanding of, it's called nuclear magnetic resonance, do you think he was saying to himself, one day we'll have machines that will diagnose the condition of the human body without cutting it open in advance? Do you think this is what was going on in his head? Of course not. It came out of this curiosity-driven research. Do you think Einstein, when he wrote down his equations for stimulated emission of atoms, he's saying to himself, hey, one day this will be the foundation of the laser and we'll have barcoding. Do you think this is on it? One day we'll have LASIK surgery. No. No. So to say the purpose of science is to improve life, the purpose of science is to understand the natural world. And the natural world has, interestingly enough, built within it forces and phenomena and materials that a whole other round of clever people, engineers, in the case of the magnetic resonance imager, these are biomedical engineers basing their patents and their machine principles on physics discovered by a physicist, an astrophysicist at that. So I take issue with the assumption that science is simply to make life better. Science is to understand the world and use that. Now you've got a utility belt of understanding. Now you access your tools out of that and use those, that ever increasing assortment of power over nature, to use that power in the greater good of our species. You need it all. It reminds me of a comic in the New Yorker I just saw. Forgive me, I forgot the illustrator. Two cavemen, in a cave, of course, sitting around a fire. One says to the other, the air we breathe is clean, our water is clear and pure, our food sources are free range, yet somehow we're not living past 30. It's like, so, I don't know. So where was I? Oh, you want me to talk about, I wrote an essay some years ago called The Beginning of Science, in part as a rebuttal to John Horgan's book, The End of Science. Yeah, I maybe it's because in astrophysics, we are so much closer and have daily reminders of our own ignorance that you would just simply never get an astrophysicist to say, science is coming to an end. It just won't happen. We're too exposed to what we don't know. Who is to say there's not some yet to be discovered law of physics that would give us a deep and intimate understanding of dark matter or dark energy or multiverses, or we're just not there yet. The 96%. If I don't know what's driving 96% of the universe, I'm the last one on your list who's going to say the end of science is near. It looks pretty much like the beginning of science to me. And at any time you assess what your scientific achievements are, this takes at least one math course to get this point I'm about to make. But I'm going to make that point anyway. If anything grows exponentially, so it's twice as big next year as it was this year, and we're twice as big this year as we were last year, so that would be an exponential growth, an example of an exponential growth. Anything that grows exponentially, if you are at the end, if you pick any spot on the timeline of that exponential growth, it will look like to you that science has made its greatest advances in the last few years, and we are living in special times because of how much we've learned just in the last 10 years. You realize that any place you slice an exponential growth, the person in that slice will say exactly the same thing. It'll look exactly the same way to them. That's what exponential growth means. So it's not that you're living in special times because you saw major advances recently. It's that the entire exponential growth curve is a special time. Your time is not more special than 10 years from now or 10 years ago. It's like saying, look at the miracles of modern medicine. Well, they said that in 1950 because they were looking at 1930s medicine. They said that in 1970 because they were looking at 1950s medicine. You wouldn't catch me dead in a hospital using 1980s medical technology. It would look primitive to things we have today. The fact that it looks primitive is evidence that we're on an exponential growth. And so I actually don't celebrate what we know today. I celebrate the fact that we're on a growth curve. And once you recognize you're on a growth curve and continue to be, who are you to say that science has ended? You just make, I don't know where that even comes from, how you even justify it. And look at how many times people thought, you're done. 100 years ago, I got the right quote in my essay. Who was it? Was it Millikan? Millikan, of the Millikan-Morley experiment that measured the speed of light being constant in every possible direction with Earth's orbit around the sun, concluding that there is no ether. A profound experiment done in the late 1800s. One of the most famous null experiment there ever was. They wanted to see the speed of light when added to Earth's velocity, subtracted from Earth's velocity, and tangent to Earth's velocity. And they got the same measurement in every direction. The speed of light was independent of the motion of the vehicle, of the vessel.
So that was Michelson.
Michelson-Morley.
Yeah.
That's correct. And they won the Nobel Prize for inventing the interferometer that enabled that measurement in the first place. They were one of the earliest Nobel Prizes given. So Millikan, Nobel laureate, did important physics, says all of physics is basically done. There are just a few clouds on the horizon, but we'll take care of that. And most any advance in physics is just that someone in that period, a contemporary of his, if not him himself. And if it's just a matter of putting in a few extra decimal places in the measurement of physical constants, then that'd be interesting. That would be, yeah, physics is done. So what would happen shortly after that? Quantum mechanics, quantum physics would be discovered. Relativity would be discovered. The expanding universe would be discovered. Particle physics would be discovered. The atom would be discovered. The electron, the proton, the neutron, neutrinos. all this happened after he said, we're almost done. That's just embarrassing. So I think the people who say we're almost done, they haven't read history, because they're just setting themselves up to have egg in their face 10, 20, 30 years from now, when we're in a whole other zone about how the universe works.
Your piece actually says 1894, soon-to-be Nobel laureate Albert Michelson.
Oh, it's Michelson, not Millikan.
It was Michelson.
Okay, so I was half right.
Michelson, Millikan. But you also went on to quote your favorite person.
But Millikan, of course, he did the famous oil drop experiment. So thank you for correcting me on that. Michelson and Morley, and we're referring to Michelson. Yes.
Right. Last time we spoke, I asked you who you wanted to bring to your dinner table, and you obviously did this wonderful talk about Newton. And in this piece itself,
Isaac Newton for dinner, for sure.
In this piece, you actually said, you actually used the great Newton quote, "I do not know what I appear to the world, but to myself I seem to be only like a boy playing on a seashore, diverting myself in now and then finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay undiscovered before me." It's one of your favorite quotes.
Indeed. That was true then, and it remains true, except the ocean of undiscovered truth is now a different ocean than it was back then.
Yeah. Do you have any other favorite scientists apart from Newton?
Einstein's up there.
Yeah.
Yeah, he's up there. I like the candor of Richard Feynman. You look at his physics, and say, hey, there's a great physicist, and then you just hang out with him, which I never had the privilege of doing, but you see videos of him, and he just would have been a fun guy to hang out with, and just to think about how he views the world. The insights that can come from someone who has that much command of the laws of physics can be quite enlightening.
Yeah. I remember
even on the levels of just what you have for breakfast.
I remember going to a birthday party for John Lilly, who was the scientist who worked with dolphins and did the flotation tank, the sort of isolation flotation chamber. It was in Malibu, and John Lilly was having a birthday party, and Feynman, Richard, was there playing bongos, as he was wont to do, and he used to use the flotation tank as well. It was kind of fun. He was a very exploratory guy. So in terms of communication of science, which you do on a daily basis, are you comfortable about the way that's going, or do you think
a few years
that
ago
the reduction of journals and so on, and newspapers sections and so on?
Yeah, all newspapers are shrinking in every way, so one can't uniquely implicate the loss or the reduction of science sections in what is otherwise, to me, looks like a ship ready to go over a cliff. The entire publishing industry in the face of the internet. So I don't think that's what's important to discuss here. What's important is 20 years ago, 30 years ago, Carl Sagan's Cosmos appeared. At that time,
1980. Yes.
Okay,
right.
That's a whole generation ago. At that time, people heard of Jacques Cousteau, and who's the guy, the animal guy? Marlowe Perkins, and Carl Sagan. And you could go months channel surfing. Of course, that's not what they called it back then. Back then it was getting up off your butt to change to turn the channel. Back then you could go months and never hit a program on science. Never accidentally bump into one on what was no more than a dozen channels. Today, practically any time you turn on your television, if you have any basic cable service, slightly above basic cable, 100 channels, 2 or 3 times a day you can channel surf and stumble on programming inspired by science, either quality science fiction or a medical program or a program on black holes, Big Bang, search for life, the galaxy, the climate. And not only that, back then there was Carl Sagan and hardly anybody else. I've been commonly analogized in my activities to what Carl Sagan had done. But the fundamental difference is when Carl Sagan did what he did, he was alone. In an academy that did not respect that kind of behavior. That is the academic world. I exist in the wake that he left behind that is wide enough for not only me to occupy it, but a dozen other people I could just list for you here and now. So that what then was the singular contribution of one man is now an enterprise. There are shows on the universe, and I'm as visible as I am. There's shows on the universe where I'm not even in them. They've got some other host, and they're interviewing other scientists. And people said, well, would you rather have been? No. The real health of bringing science to the public is when it's not funneled through one person, when there's a base of people who you can tap, when your Rolodex that's wielded by the gatekeepers of news and the film production crews, when their Rolodex has multiple people to select from, and I'm just one of a dozen, then you know the communication of science is healthy and growing. When one of the most successful series on the History Channel, at one time thought of as the Hitler Channel, because all their shows seemed to be on the Second World War, when one of their most successful series ever put forth is on the universe, I can only praise that fact. So you ask, how are things going? I think they're going very well. Better than I would have projected for it. And I don't measure that by how many times I'm asked to appear. I measure that by how many times my colleagues are asked to appear. I measure it by how many of my colleagues now care about their ability to deliver, if not a soundbite, certainly an account of their field that is accessible to an uninitiated public. And I do it, as best as I can judge, without cost to my professional standing. It doesn't always accrue to it, but in the days of Carl Sagan, it certainly would have subtracted. At least now, in astrophysics, it is neutral to your professional standing. And that's all I could have hoped for, coming in the wake of Carl Sagan's pioneering efforts. And by the way, I don't see the same thing in other fields necessarily. I don't know that other fields, since they didn't have a Carl Sagan pioneer, I don't know that they treat their own colleagues in the same way. I don't know that it's happening that way in biology or chemistry or geology. I don't know, and I don't think it's at the level that we enjoy in the astrophysical fields.
We did a panel recently, which is still on the Science Network homepage, which is on the origins of morality, and there was Steve Pinker, Pat Churchland, Sam Harris, Simon Blackburn, Peter Singer, Lawrence Krauss, and it was in Arizona at ASU, and the Hall Gamage Auditorium, and there was over 2,000 people turned up for that. So there's obviously a need out there for this sort of thing.
More evidence. I would say not so much a need, but an appetite. Appetite for getting closer to the frontier through the efforts of physicists, scientists who are on that frontier. It's not being interpreted by a journalist. It's the scientists themselves. And that's the evidence that the value of bringing science to the public has made its way deep into the inner sanctum.
I asked you this question last time. I'm going to, if we look,
and you know, because it's on the transcript.
If we look back at the transcript or watch the thing again, God forbid. But let me ask you again. What are you optimistic about?
With regard to, could you be a little more specific?
Well, all right. To your discipline, to your function as a communicator. I mean, I'm
optimistic. every next day that I'm alive, I see more and more people valuing what science means to the world and to them. I see more and more people rising up, no longer simply accepting fuzzy thinking in the world. There might have been a day, for example, where Bill O'Reilly would have said, tide goes in and out, you can't explain that, and it would have gone uncontested. So the change is not that people aren't still saying underinformed things. The change is that if you're in power and you say something underinformed, there are people out there with a voice who will take you to task for having done so. And at the end of the day, that can only make a stronger society. A society that is the kind of democracy you want to live in, where people vote from an informed platform and knowing the difference between something that is their opinion and something that is a fact. The famous skeptical mantra, you're entitled to your own opinions, but not entitled to your own facts. And not enough people understand that distinction. I see a strong enough movement, so I'm optimistic that clearer heads will prevail as we go forward. And a very natural consequence of being clear-headed is being attracted to the fruits of science, because that's as clear-headed an enterprise in this world as there ever was.
Which is a great note to close on. Thanks very much, Neil deGrasse Tyson.